Welcome back, Algebra Express. We are in Marecek 6.1. So last time we left off, we were talking about distributing. And so just a little recap. If we have something, I don't know, x minus 1. And I don't believe I did it last time. But one of the ways we can look at this is what they refer to as the box method. And so if we have something like x here, plus 3, and we have something here, x minus 1, we get x squared. By multiplying x by x, we get plus 3x here. By multiplying x and 3. And so you're just multiplying row and column to get the new entry. So minus 1x is going to give us minus 1x. And this is going to give us minus 3. And whether you do this with the box or distribution, you're going to have some terms that you have to combine. So this would be like x squared. I have a plus 3x and a minus x is going to give me that plus 2x. And the last thing I see here is a minus 3. So this is one way to do distribution. It's a bit more of a visual way, I guess, or geometric way than what I was doing. The way I was doing it. And so I believe doing it this way might be a little faster. This way you're going to have to draw more stuff. But it's going to lead into where we're going next. This process would be called distribution. If I want to go the other way, it would be factoring. So let's do that. So this would be the distribution. Factoring. So we can go back and forth through algebra. What I'm trying to say, they are the opposite steps of each other. And so if I ask for the factored form, I'm going to be talking about this thing, and we'll talk a little bit what it means to be fully factored in the future. And if I talk about the distributed form, I'm talking about it fully multiplied out. And so they are kind of opposites of each other. We did a whole section on distribution. This next 3 sections, I believe, are going to be on factoring. And then after the next 3 sections, a lot of the stuff that we're going to do after that is also on factoring. So this is, I want to make it clear, like this is going to be a big part of this course. So if you're not understanding something, now is the time to ask questions. Like get this down. This is going to come up and it's going to come up again. And it's going to come up again and again. And if you don't learn it the first time, you're not going to get it right the second or third time. And it's just going to keep compiling on. Don't do that to yourself. Get this down. Like understand this stuff. Do some good practice with this stuff. Okay, so we want to find the GCF between 24 and 36. And so previously, I think I've done this, but let's go through it a little slower maybe. So I want to find the prime factorization of 24. I want to find the prime factorization of 36. And so I can construct a prime tree. 24 is not too bad. I can do 3 and 8. 3 is prime. 2 and 4, and I'm going to have to break that down further to 2 and 2. My 36. Okay, if you pretend like you don't know what anything, pretend like you don't know any factors at 36. If something is even, you can always take 2 from it. So we do 2 and 18. 18 is even. So one trick you can kind of do is if it is even, take a 2 out. 2 and 9, and it boils down pretty quick usually if you take out your 2s. Especially in this class, we're not going into anything too crazy high. So I want to rewrite these. So 24 I can rewrite as 1, 2, 3. So I have 3 2's being multiplied together. So I could write them all separately, but I want to write them all kind of as one thing. So I have 2 to the 3rd, 3 first. So I'm going to write my power on there, even though I usually won't. It would be 2 to the second times the second. Okay, so if I want to find the GCF of these things, the first step is defining the prime factorization. So do a prime tree, look at the bottom of your tree, look for your primes, and write them out like this. So you might notice also I have them like my 2's under my 2's, my 3's under my 3's. Space them out like that, right? Space them out appropriately with the same numbers over each other, the same base numbers. Do yourself a favor, write things in a pretty way. Don't try to cram things. Okay, so I want to take out a factor. So this thing has to divide each of these things. So if I think about this, I'm looking at 2 squared versus 2 to the third. So I want to think about what is the most I can take out of there. So it's either 2 squared or 2 to the third. If I think about 2 to the third is 8. 8 divides 24. 8 will not divide 36. So the most that I can take out, and I've said a lot of words just to get at this, the most I can take out is 2 to the second. And if we look at those numbers, that is the smallest of those two numbers. And there is a certain reason for that, right? I can only take out as much as the smallest one that is there. Same thing here. If I look here, I can't take 9 out of 24. I can only take 3 out of it once. And so if you do your prime factorization, what you're doing is you're looking at the smallest exponent of each base. Okay, and so if we look at this, my GCF is 2 squared times 3. This is 4 times 3. So my GCF should be 12. And if I look at 12, 12 is going to divide 24, and it's going to divide 36. Now I want to find a GCF between 52 and 16. So I'm looking at this thing. I want to do my tree first. So if I want to do my tree, I'm looking at the number 52. And I'm looking at the number 16. So we can talk about the variables in just a second. I'm not putting them on here. I'm just putting the coefficient. That's the main thing that I want to kind of break down right now. So 52 is a larger number. I don't know what would divide it besides maybe like 2 and what, 26. And if I do 2 and 26, 26 is going to be what, 2 and 13. And if I do 16, I can do 4 and 4. And if I break down each of my 4s, each one of these will give me 2 2s. So if I'm looking at these things, the 52 boils down to, I got 2 2s there, and I got 1 13. My 16 is going to boil down to 2 of them. I got 2 4 times. And now I can write the other stuff there. So x squared y to the first is on my 52. And on my 16, I have an x to the first, y to the third. And so I'm finding my GCF exactly the same way. If I boil things down to primes, I'm taking 2 squared out of this thing. I'm looking here. How many 13s can I take out of this thing? If I try to divide 16 by 13, and I don't have it written here, but if I wanted to, I could write a really stupid thing. There is no 13s in this thing, right? There's no 13s in 16. So I cannot take out any 13s. So I'm always circling the smallest exponent. Same thing with my variables. I'm always circling and taking down the smallest exponent. So I'm not going to write this again. This is just a stupid way to write 1. This is x to the first, this is y to the first. Okay, so maybe clean it up. What this is 4xy, I believe. So that is my GCF. That's all they're asking for here. They're not asking for us to factor it out yet, right? They're just asking to find the GCF. Now we're going to do a little bit of factoring. So find the GCF of the coefficients. No, not even doing factoring yet. Sorry. So we want to find the GCF of these things between 8 and 4. Oh man, so we could do a tree here. 8 is 2 to the third. Let's just get at it. And 4 is 2 squared. So if I do 8, that's 2 to the third. I have x to the fourth, and I have a y to the first. So I think we're going to go ahead and factor these guys. And if we look, we have an x squared and a y squared. So these are my two things. If I want the GCF, it's going to be 2 squared. Between 4 and 8, it's going to be 4. Between x squared and x to the fourth, it's going to be x squared, and it's going to be y, excuse me, to the first power. So my GCF looks like 4x squared y. So we want to pull out 4x squared y. If I'm pulling this out, each of these, you can think about it as like I'm kind of dividing each of these terms by a 4x squared y. And so the first thing we're doing is we're dividing 8 by 4, which is going to give me 2. I'm doing x to the fourth over x squared. So this goes back to my exponent rules of 4 minus 2 is going to give me x squared. And I have y to the first over y to the first. That is going to give me no more y's. The next thing I have is minus 4 over 4 is going to be minus 1. I have x squared over x squared. There's no more x's, but there is a y. So minus 1 y would be how this thing factors out. Okay. And same thing for the next thing. Now we have 3 terms. So we're looking at 3 terms. There are a few ways to find the GCF of this thing. If you want to do prime factorization, you can do a prime factorization for each of these numbers. Well, let me move it. You can do a 2 and 9, 3 and 3, 2 and 15, 3 and 5. So between 2 squared, 3 to the first, between 2 to the first, 3 squared, and between 2 times 3 times 5, we're looking at all these numbers, and we're going to select the least of each. And if we're looking here, we can pull out 1, 2, and we can pull out 1, 3. We cannot pull out any 5s. So my GCF for the numbers should be 2 times 3, should be 6 for the numbers. And if we're looking at these numbers, 12, 18, and 30, if I asked you for the GCF, what is the most you can factor out of both 12 and 18? You could probably tell me 6 right off the bat, I think. So between 12 and 18, it's going to be 6. So if this helps. And so if I'm looking at that, between 12 and 18, it's 6. Now I'm looking at between 6 and 30. So if you want to take 2 at a time and find their GCF, you can do that as well. That's another way to set this up. You can take 2 at a time, find their GCF, and now we're looking at a GCF between 6 and 30. So if it helps to look at 2 at a time, that is absolutely an approach you can do. already found between 12 and 18. We found that that was 6, and so then we compared that to the next number. And the GCF between 6 and 30 is going to give you 6. There are a few ways you can go about finding the GCF. The prime factorization will always get you there. So we'll take in the two GCFs. The GCF between two numbers. So the GCF between these numbers is 6. So we want to factor out the number 6. If we look at our variables, we have 3 x's, we have 2 x's, and we have 1 x. And I don't need much room here. But on my outside my parentheses, I want to factor out 6x. Each of these things by a 6x. If I divide 12 by 6, I get 2. I have 3 x's. I take away one of them. I have 18 divided by 6 is going to give me 3. I have 2 x's. I take away 1. That's going to give me 3x. Minus 30 of 6 gives me 5. I have 1x minus 1x. I have no more x's. Okay, so the next problem, we want to find the GCF between 6 and 11. So if you break down 6, it is 2 times 3. 11 is prime in itself. So if we look at this, we have 2, 3 over here, and we have 11 over here. So you might ask, where did those match up? Those don't match up anywhere. There is no common factor between 6 and 11. So if we're looking, and it kind of gives you it away right here. If the first term is negative, we want to factor out a negative. So if there is no common factor, the only factor between the two is going to be 1. And we want to factor out a negative. So we're going to factor out a negative 1. We also have to pick between our variables. So we have 2 x's here and 2 x's here. So I believe overall we can pull out 2 x's. If we have, and here we're putting in exponents, we have 1 y and we have 2 y's. The most we can take out is the smallest one, is the y to the first. Same thing here, we have z squared and z to the first. The most I can take out is the smallest one, being z to the first. So I want to take out a negative 1x squared yz. So this is my GCF. This is the thing I want to take out. So I'm going to do this. Negative x squared yz. I want to take this thing out. So the first thing, when I take out a negative 1, this 6 is going to swap to positive 6. So if the term leads with a negative, we take out the negative. If we start with x squared and we take out an x squared, we have no more x squareds. If we have 1y and we take out a y, we have no more y's. But the z's, if we have z's, we have 2 z's minus 1 z. There will still be a z on this 6. The next thing is we're taking out a negative 1 from this 11. So this 11 is going to become negative 11 now. We're taking out an x squared from an x squared. There are no more x squareds. We start with 2 y's. We're going to take out one of the y's. So one of them will still remain. The next thing is my z's. There's 1 z minus 1 z. No more z's. I think they meant you to factor out those problems, if I'm being honest. I remember factoring them out previously. See, here's even the student activities, Jay. I don't know why I didn't say that. I thought I did say it. Huh? So, we're looking at this thing. So technically, y'all should be doing these on your own at this point. You should be able to do this. I showed you 2, 3 examples of factoring things out. I showed you 2 examples of finding the factor. So if we're looking at this between 6, 12, and 18. So if I'm doing this, what I'm going to look at is that number first. I'm looking at between 6 and 12. I know my greatest common factor between 6 and 12 is going to be 6. I can't take 12 out of 6, but I can take 6 out of 12. So that's going to be the largest thing I can take out of both of those. So 6 is my greatest common factor between these two things. And 6 is also going to be my greatest common factor between these two things. It is going to be the largest thing I can take out of everything. The other thing is this leads with a negative, so I need to take out a negative. And now I'm looking at A's. I got 3, 2, and if it's not written, this is where you're going to have to start filling things in. I have 1A there, so I want to take out a GCF of minus 6A. So I take out minus 6 from each side. Minus 6. Ooh, my A. I got to take out a minus 6A, and what is left when I do that I got 3A's minus 1A, give me A squared. So I have 1A squared. This is minus 12 and a minus 6. So overall, this should be positive. I have 12 divided by 6 gives me 2. A squared minus A to the first is going to give me A. 18 divided by minus 6 should give me a minus 3A over A gives me no more A's in that one. And I talked about it at the beginning, but if we wanted to sort of check our solution, if we're looking at these things and we factored them out, factoring is going one way, distribution is going the other. So if you multiply these things back through, you should get back up to this thing, right? And if you multiply this thing through to each of these terms, you should get back up to this original term. So we're multiplying to get to here, we're dividing and factoring out a term to get to this thing. Going one way is going to be multiplying, right? That would be distribution. This way is going to involve some division of some sort. So we're dividing terms by terms. We're getting to things that are smaller powers. That's kind of the goal, is to get these things and break them down into smaller sort of things. The next thing looks like 5x squared. So GCF right off the bat, the number between 5 and 30, I'm hoping it jumps out. It's going to be the 5. X squared and x squared, I can pull out a x squared. Between y to the first, and no y's. Between z to the first and z squared. So I think this might be the first time I throw this at you. But if I put y here, am I going to be able to factor out a y from this term, 30x squared z? So if I try to factor out a y, it's not going to look very pretty. It's not going to be able to factor it out, right? So I cannot put a y. And if you want to, this is that sort of thing I was talking about. You can think of it as y to the 0. There are no y's on that term. But between my z to the first and my z, I can factor out a z. Probably erase this thing. I'm going to reuse this. Divide this by what? 5x squared z is what I'm pulling out. 5x squared z. And if I'm looking at this, this is 5x squared z is what I'm pulling out. What's left over is 5 over 5, x squared over x squared. I have a y over 1. So I can pull my y down. I have a z over z. I have no more z's. And this is the sort of thing, if you want to hack and slash, you can kind of hack and slash this thing. You can go 5 over 5, 2 x squared over x squared, 0 over z, right? And the only thing you don't have marked out is going to be that y. and it's on top, so you're safe with just bringing it down. The next thing is minus 30 divided by 5 is have an x squared over an x squared. That will simplify out. Z squared over z to the power of z. Oh, okay. So we have factored out a greatest common factor. And so far it has been a monomial common factor. Now we want to look at things that are larger, so they're going to start us out with two terms. So now we have a thing that involves two terms that we want to factor out. So if we look here, they say the common thing between and so this is the sort of same thing we're doing. We're pulling out an and so if we're pulling it out, the thing that we want to do is we're essentially dividing each of these terms. And if we look, this is the thing over itself. So if I'm pulling it out, what I'm left with is going to be what's remaining is x plus 2. Terms. You want to notice I put parentheses around this thing and I put parentheses around this thing because this is multiplication between these two terms. So a lot of times people will drop their parentheses or do something silly and start adding these two terms. When we factor things out, it is the operation of multiplication and division. These things are being multiplied and divided. Okay. So you have one example, so hopefully you're checking out this next example, trying to get through it on your own. If we look at this, what is the thing they have in common? 2. So this is the thing we want to pull out. We have b minus 2 that we're pulling out. Now we're asking ourselves, what is left over? B minus 2. What is going to be left over is that 3b minus 13. And so we're factoring these things, They start with the GCF. And now we're going to go to 4 terms. In the next section, I believe we will start doing 3 terms. So 3 terms, I believe, are probably one of the more difficult, or they're one of the more involved, factoring that we do. The 4 terms, they really have to fit a pattern or we can't do them. So it's either we can do them and it's going to be fairly straightforward, I hope, or we can't do them and we just stop there. We say not factorable and we're done. Until we get a little further, maybe, then they might be a little bit more factorable. But for the most part, we're going to do 4 terms. If they don't fit the pattern, we're going to reject them. We're going to do 3 terms. And 3 terms are going to be a little more difficult. But the process basically is to make 3 terms into 4 terms. And then we do the same process that we're doing here. So like I said, these things are going to come up and they're going to come up again. So we really need to learn them the first go round. And then after we do 3 terms, we will do 2 terms. And 2 terms is kind of the same thing. If they fit the pattern, then we can do them. If they don't fit the pattern, then we say they're not factorable or we say they are prime. And so we're doing all this factoring. And just to look a little bit ahead of factoring, which is like more than 3 days, more than 3 lectures worth away. But, after we do factoring, we're doing this factoring. And factoring doesn't do anything besides rewrite this term. So all we're doing is rewriting terms. After we do factoring, we're going to start talking about what it means to solve these things. So that's the direction that we're going in. We're going to start equaling these things to numbers and start solving them. But we should know what it means to solve things, right? It means to find an x that makes it true. Okay. So we want to factor 4 terms. the way that we factor four terms, what do they say? Group the polynomial. Okay, so the first thing you want to make sure is that you are in the correct order. So this, they're going to start you out with the correct order because they're not trying to confuse you. But this says x to the third, x squared, x to the first. And then really, if I wanted to, I could say x to the 0, or it's my constant term, right? But you want to make sure they're going 3, 2, 1, x, no x's. So you want to make sure it's in descending order. We want to make sure there is a GCF. So between 2 and 10, the only GCF between 2 and 10 is going to be 2. The second we throw in 3 in there, there's no common GCF between 2 and 3. So the second there's no common GCF between two of them, there's no common GCF between all of them. So for the 2's, there's no common GCF. There's no x's on this last term, so we cannot pull out an x from everything. So there is no GCF. Now we want to see if there is a binomial hidden in here. So like the previous sort of thing we did, or it should look sort of like the previous thing we did with the binomial, but it's kind of hidden in here. And so the way that we kind of bring it out is we factor by grouping. So if you have four terms, the first thing I want you to think is we have four terms, we're factoring by grouping. And so I hope that gets stuck in your head somehow. If we have four terms, group the first two, group the last two, try to pull out a common factor between the two. Look at 2x to the third and 10x squared. So if we're looking at this thing, my GCF, I'm going to write in red right here, my GCF between 2x squared would be a 2 between 2 and x squared between the other two. So if I pull out a 2x squared from both of these terms, what I'm going to be left with is 2 divided by 2 gives me no more constant coefficients. So x to the third, and I'm going to subtract 2 of them. Give me a x plus, and I go 10 divided by 2 is going to give me 5. X squared divided by x squared is going to give me no more x's. Okay. And now I'm done with these two numbers. Now I'm looking at the next two numbers. So I want, first off, there is still a plus sign here. We haven't factored. It is still addition, subtraction between these two things. Between 3 and 15, I can pull out 3. Between x, 1x, and no x's, I cannot pull out any x's from both of these things. So if I pull out 3 from this thing, 3x to the first divided by 3 is going to give me an x. If I pull out 3 to 15, it's going to give me 5. And now we're looking at this thing. This thing should look like the thing we were doing on the previous page. So if you notice, my x plus 5 is the thing that I have in common. So I can pull out an x plus 5. And now we've done the factoring thing. Now the operation between these two things should be multiplication. We're pulling it out, and what I have left is something that looks like 2x plus 3. And so I have factored the first 4-term polynomial. Okay. Now, hopefully, you can try this on your own, right? We're going to group the first two. We're going to group the last two. Factored by grouping, you got 4 terms. Find your greatest common factor between the first two, but between 16t to the third and 8t squared. I can pull an 8 out of this, and I can pull a 2 squared. By 8, that's going to give me 20. T left under. 8t squared divided by 8t squared. This is where you don't want to forget your subtraction sign. We have minus 8t squared. This is going to be minus. This number itself should be 1. Now we get to this point. Between 6t n plus 3. So between 3 and 6, I can pull out 3. Between t and no t, I cannot pull out any t's. So if you try to pull out 3, you might notice minus t. And this is because you shouldn't have pulled out a positive 3, right? And so this goes back to what they were saying on that first page. Oh, if you notice, these things don't match up. And so these things are not exactly the same. A step with factoring them, right? It has to be exactly the same to do this factoring. If they're not exactly the same, right? They got to be exact. Everything has to match. If they're not exactly the same, we cannot factor them. So since this is positive, negative, negative, positive, it's not going to factor out like that. So I said here we should have factored out not positive 3, factor out a minus. And if you factor out a minus 3, right? Don't do that. This is minus 6 divided by minus 3 is going to give us the positive 2t. And now we do positive 3, and we're going to divide it by negative 3. That's going to give us minus 1 we want. And now we have the same thing matching up in here. And so now, since we got the same thing matching up in here, we can pull that thing out, which looks like 2t minus 3. We are doing the factoring stage. This is when it becomes multiplication. So this is 8t squared minus 3. Okay, so now we are on number 12. I'm kind of joking. I want to go back to number 11. I want to go talk about this maybe in a different sort of light. So I talked about the box earlier. If you want to put this thing in a box, that is another way you can factor by grouping. So 6. You have to make sure it's in these things. Right. Minus 16 plus 3. And if you do it this way, now we're looking across here, we're looking for a common factor between 6 and 16. This is where it comes, I mean, what, 2 t third and t to the first. This gives me a t to the first. So I'm finding the greatest common factor between these things. And I'm finding the greatest common factor between these things. Should give me 2t. If this leads with a negative, I want to take the negative out. There is no common factor between 3 and 8. There's no t's here, so I can't take out anything. Here, I'm looking across. I can take out 8 between 6 and 8. I can take out 18 squared between those two things. I'm looking across here. These are the negatives. I can take out a 3 from both 6 and 3. And if I'm looking at this, this is the distributed version in here. Out here are your polynomials that you're looking for, right? Your factors. So this is 2t minus 1 is what's written on top here. And 8t squared minus 3 is what is written on the side over there. So if you want to use the box method for these things, you can use the box method for these things. And if you want to, this is also a good way to check your solutions, right? If I want to go and multiply things back through, 8t squared times 2t, it's going to give me 16t cubed. 8t squared minus 1 times the minus 1 is going to give me this. Minus 3 times 2t gives me this. And last but not least, negative times negative makes this positive 3. So we can sort of look back at what we're doing. We can, I think the distribution is the more straightforward way that people tend to see this thing. The factoring tends to be sort of the new sort of thing that's getting thrown out at you. I think people have a little more difficulty with it. So being able to check things through distribution usually favors you because you can relate it back to something you know, right? Okay. So we did that. So we are on number, what, 12 now, I believe. Okay, the last page. So this is student activity. They want you to factor by grouping. And so I want you to try this on your own. And if you try it, they're doing something a little tricky with this one, maybe. Something they hadn't done previously. We start with 3x cubed. And the next thing we have is this thing with no x's. I don't know. What we really want is to go 3 to x, which is plus 3x, and we want to go to the thing with no x's. So we want to kind of rearrange this thing so that it is in 3, 2, 1, no x's, descending order. If it's in descending order, we can take out the GCF. If you try to do that previously, your GCF is not going to match up. It's going to look like it's not possible. But it is possible. So let's do it. Between 3 and 7, there's nothing we can take out of that. They have no common factors. Between a x cubed and an x squared, we can take out a x squared. If we take out an x squared, that's going to leave x. This one and this one, we cannot take out anything. We can't take out a constant between 3 and 7. We can't take out an x. The only thing I can take out is a GCF of 1. So my suggestion is to go ahead and take that out. And so we are still adding. Don't forget your addition. And I'm going to take out 1. And I'm going to write it there. And it might seem silly. But this next step is going to where you're going to see it really comes. If you don't write the 1, it might be hard to see it. But we're going to pull out 3x minus 7. And what we're going to be left with is x squared and plus 1. And so that plus 1 makes all the world of a difference. Okay, so make sure it's in descending order if it's not in descending order. The other thing is if you can't take out anything, a GCF, always pull out 1 when we're factoring things. So those 1s are important. Now we're looking here. The first thing we ask, is this in descending order? The other thing we should probably really ask, is there a GCF out of all of these things? So I didn't really ask that with that, but we had 3 and 7, and the second we see 3 and 7, there's no GCF between 3 and 7. Same thing here, we have 2, 3. Between 2 and 3 already, there is no common factor right there. It's already 1, so there's no common factor between 2 and 3. If we look at the x's, there's no x's on this last term, so there's not an x I can take out of everything. So the GCF. They'll probably try to catch us on that one after we get used to just doing these things. But we check it. We look at these. We group them up, the first 2, and we group up the last 2. Now we look at the GCF between just 2 of them. So between 2x to the third and minus 3x squared, I can take out an x squared. If I take out an x squared, it's going to drop this by 2 powers of x. It's going to drop that by 2 powers of x. It's going to leave me with 2x minus 3. Here is the same thing again. I'm leading with a negative. So overall, I'm negative. So I'm going to skip doing an elaborate explanation on that thing again. But I want to lead with, if it's leading with a negative, take out a negative. Between 4 and 6, I can take out a common factor of, I'll take out a minus. minus 4 is going to be positive 2x on this guy. And if we did things correctly, minus 6 divided by minus 2 is going to give me. Ooh. So we're looking at this thing. Did I do this correctly? Let's see. Yeah, that's correct. So what is the thing? What are we looking at here? Can I do this? X minus 3, 2x plus 3. So maybe they're trying to be a little tricky because it's off by just like a negative sign, right? But like I said, if they are not exactly the same, at this point, we're just saying not factorable. So this is going to be one of those things we call not factorable. If you want to say prime, you can say prime. Either way, cannot be done. So we are done. We don't need to do that anymore. Oh, look, that was the next problem that they're trying to catch us with the GCF. So if there's a GCF between everything, if you try to do this 2 by 2, might work, it may not work on this one. So we're looking at this. We're looking here and we see 15t to the fourth plus 18t cubed minus 5t squared minus 6t. What is it? Do they all have in common that we can take out? So between 5 and 6, I can already tell you there is no constant that they have in common. But if I'm looking here, 4, 3, 2, 1 here, they all have a t that I can factor out. So if I factor out a t, that's going to drop everything by a power of t. It should look like t times 15t cubed plus 18t squared minus 5t minus 6. I'm pulling out a t from this thing. I'm grouping them 2 at a time. Between 15 and 18, I can pull out 3. I can pull out t squared. I pull out 2t squared, that's going to leave y. Pull out 3. And so if you factor out a GCF first, if I pull out, well, this is leading with the negative, so I'm going to pull out a negative 1. Between 5 and 6, there's no common factor. Between t and no t, there's no common factor. So the only thing I can pull out is a minus 1 from this thing. And if I pull out a minus 1, that's going to make this 5t. That's going to make this plus 6. And again, you can always sort of check. If we redistribute this thing, we should end up right back here. So if you want to check your negative signs, doing distribution to get back to what you just got to might be a good sort of mental check. Now we're looking at this thing. And you should be able to factor this thing, 5t plus 6. And if I factor that out, I should be left with the 3t squared minus 1. And if you did this, you would be mostly correct. There's something I did that was a little tricky, and I should have brought it down. Probably right here. There's this t that's tagging along for the ride for the most part, right? We're like really crunching this thing on the inside, and we probably lost sight of him. But he was there. He was there when we first started our trip. We got to make sure he ended our trip, right? Or we're gonna have to go back and search for him somewhere along the road. So he's there. Don't forget about him. He's all by himself, all lonely. Right? So let him tag along. Don't forget him. You got to bring things down. So if you do factor out a GCF, I think the rule that the lesson that they're trying to teach you on this one is if you do factor out that GCF, make sure it is there at the end. Like you're going to start doing all this hard work in here, and you're going to forget all about that easy thing you did at the beginning. All right. That's the way our focus is, all right? We are sort of one-track creatures, I feel like. So besides that little tangential philosophy there, that is fully that's fully factored for us right now. we did some group factor by grouping, right? All right, I will see y'all next class, and I'll see y'all next lesson. Take care, do some math, and enjoy your time.